Good morning, my dear students. So, in this second presentation of Module 1, that is Static and Dynamic Force Analysis. So, today I am going to cover the following topics. That is, first what? Static equilibrium condition and equilibrium of two force member, equilibrium of three force member, and member with two force and torque. Okay, so what is the condition for these four topics? Okay, that is, if you take any mechanical component, so if that force is in under static equilibrium, then when we are going to say that is a static equilibrium condition. Okay, so again similarly, two force member. Okay, if take any one mechanical devices on that, there are two forces are acting from the different sources, then if you want to make it that one as a static equilibrium, that is an equilibrium, then what is the condition for that? Okay, similarly equilibrium of three force member. Okay, take any body upon which there are three forces are acting in different direction. If you want to make that one as a equilibrium condition, then what is the condition? Okay, similarly last one is member with two force and torque. Okay, take any mechanical element, that is a link or element upon which there are two different forces are acting at a different direction, and it will produce a torque. Okay, if you want to stop that, then what is the condition? Okay, so these four methods are very important for the point of examination, and these four concepts I am using to while solving the problems. Okay, so let me understand one by one. Okay, static equilibrium condition. Okay, so here, so look at the static equilibrium. Okay, so we know that what do you mean by static? So it is a rest in position. Okay, in the first slide I told you what you mean by static load and dynamic load. Okay, so static equilibrium. Okay, take any one mechanical devices. Okay, if you take any one mechanical devices upon which there are two forces are acting, or a number of forces are acting on that particular component. Okay, so when we are going to say that as a static equilibrium. Okay, so when the vector sum of all the forces acting on the body is zero, that means what? A number of forces acting on that particular element or device in a different direction, that should be equal to zero. That is, suppose if three forces are acting on a particular component, means just while solving the problem, that is while if you add those forces, it should be equal to zero. That is, f1 plus f2 plus f3 is equal to zero. Okay, this is the first condition. And second condition is what? The vector sum of all the moment about any arbitrary point is zero. Okay, if these two conditions are satisfied, means then the given mechanical device is in a static equilibrium condition of any component. Okay, that is, what is the condition? The summation of forces acting on that particular component should be equal to zero. That is, f1 plus f2 plus f3 and so on is that should be equal to zero. And the moment, take any, if it is two element member, means if that is two forces, if you want to twist it, that there is a torque to be produced. Okay, so that the moment about any arbitrary axis, that should be equal to zero. That is, summation of forces is equal to zero and the summation of moment is equal to zero. Okay, if this condition is satisfied, then we are going to call as that one is a static equilibrium condition. Okay, so okay, suppose in the same condition in a planar system, means all the forces, that is all the forces acting in different directions should be equal to zero. That is, the sum of the forces acting along the x direction is equal to zero, and the summation of that is the forces acting on the y direction is equal to zero, and the forces acting on z direction is equal to zero. Okay, if these three conditions are satisfied, then only we are going to call a static equilibrium condition. Okay, in examination they may ask you what is the condition for static equilibrium. Okay, so you have to write these 2 points, that is, the summation of forces acting on an element is equal to zero, and the moment which is acting on any arbitrary axis should be equal to zero. Okay, suppose if you consider 3D diagram, that is any planar system, that is okay, then you can write the summation of forces acting in x direction is equal to zero, and the summation of force y and acting on y direction is equal to zero, and the summation of forces acting in the z direction is equal to zero. Okay, if this condition is satisfied, means then we are going to call as the body is in a static equilibrium. Okay, so next one is, second one is what is the condition for two force member. Okay, so member nothing but what, you can some book they may use member, body, system, component, element, all words are same only. Okay, so here look at the diagram here. So this is a body. Okay, upon which one force is acting this direction and one more force is acting this direction, that is fa and fb. Okay, otherwise if you take f1 and f2, okay, 1 2. Okay, so this is the device. A member under the action of two forces will be equilibrium when, so that is the condition they may ask in the examination. Okay, so the first condition is, look at here, the forces are of the same magnitude, the forces acting along the same line and the forces are in opposite direction. Okay, if these three conditions are satisfied on a given mechanical device means then we are going to say this body is in equilibrium condition. That is, the body will not move from one place to another position. Okay, so that means what? So what is the condition? First condition, the forces here, the Fa and Fv should be same side, that is the same magnitude. That is, if suppose Fa is equal to 10 Newton means Fv should be always equal to 10 Newton. Okay, and the second condition is what? Both the forces acting on the same line. Look at here, the dotted line I shown here. Okay, the both the forces are acting on the same line. Okay, and the third condition is what? The both the forces should be act opposite to each other. Okay, then only we are going to call as the two force member is in equilibrium condition. Okay, so I will repeat here. If state the in examination they may ask you state the condition for two force member anta. Okay, you draw this diagram. So this is any device or any mechanical device, element, body, system. Okay, upon which the two forces are acting on a body. What is the first condition you have to write? Both the forces should be same magnitude. That is, for example, the force 1 or the force A is acting 10 Newton, then force B is also should be there. That should be force B should be always, it should be equal to that Fa, that is 10 Newton only. Okay, suppose if Fa is 20 and Fb is 10 means that is not in equilibrium condition. Okay, both the magnitude is same. And the second condition is the both the forces should be acting on the same line. What? The force F1 is acting on the line on the body, Fb is also should be act on the same line. Okay, I shown here in the dotted line. Okay, it should not be acted this side, there is a horizontal direction. If this side, if it is F2 force is acting this side means the body will fluctuate, the body will vibrate. Okay, that is not in static equilibrium condition. Okay, so third condition is what? They are opposite to each other. Okay, both should be in opposite to each other. Okay, if these three conditions are satisfied means we can call the given particular body or a system is under equilibrium condition. That is, two force member is in equilibrium condition. Okay, so next third question is state the condition for that is what? Three force member. Okay, so what is the condition? Look at the diagram here. First A. Okay, so figure A shows what? Here the three forces are acting on a given body or a given system. Okay, in different direction. Okay, but the body is in, if you want to make this body is in equilibrium condition means we have to extend this line, or just all the three forces should be act at a point. That point is called as point of concurrency. Okay, suppose F1 is acting this side, so just to extend the line. Okay, and F2 is acting on this direction, just to extend the line, and F3 is also acting this direction just to extend that line. Okay, if all the three forces acting at a point, okay, then we are going to say that body is in equilibrium condition. That is static equilibrium. Okay, that means what? All the three forces acting on particular given element should be meet at a point. That is at a point means at some position. All the forces should be meet at single point. Okay, that point is called as point of concurrency. Then the body is in equilibrium condition. Okay, so suppose you look at the figure third one. Okay, here F1 is acting this direction and F2 is acting this direction. Okay, F1 and F2 meeting at point. Okay, one point, that point is called as O. But whereas F3 is acting in middle of this, but this we cannot call as the body is in a static equilibrium. Okay, what is the condition? So if the three forces acting on a given body, so when we are going to say that body is in a equilibrium member, it should be meet at a point. But here, whereas in the third diagram, only the two forces are acting at a point, but the third force is not acting at the point O. Okay, so because of this the body will movement takes place. Okay, so this is not in equilibrium position. Okay, so this is a wrong. So figure C shows that what? The body is in not a static equilibrium condition. Okay, so figure A, what is the condition? Here I wrote here, a member under the action of three forces will be in equilibrium if the resultant of the forces is equal to 0. That is, if you add all the forces, it should be equal to 0. That is, F1 plus F2 plus F3 is equal to make it the 0. Okay, the line of the action of the forces interact at a point. Okay, this is very very important line. The second sentence you have to write in the examination. Okay, the line of action of the forces intersect at a point. Okay, so you look at here. So all the three forces are acting at point. That point is called as O. That is called as point of concurrency. Okay, all the forces acting on a given body or a system should be meet at point. Okay, then only we are going to say that the body is in equilibrium. That is, the three force member is in equilibrium. Okay, so whereas look at this, the only two forces are meeting at point O, but whereas the F3 is not meeting at a point O, so this body is not in equilibrium condition. Okay, so once if you draw the this equilibrium condition, you go for the constructing the force polygon. Okay, look at here, the F3 force is there. Just F3 force, okay, just to write here, this is a free body diagram. Okay, so F1 F3 is acting this direction, and F1 is acting this direction from this. Okay, so just to draw line F1 like this, and F2 is acting this direction, F2 is just to draw. Okay, if this triangle is closed, it should be closed one. Okay, it should be closed one. Okay, then only we are going to say this, it is called as force polygon. Okay, so and one more observation you have to look at here, the force, you see, look at the direction here. Okay, one first force direction is like this side, and the next direction should be, it should be in forward direction only, it will not come opposite direction. Okay, so just one another to each other. Okay, that is the first direction is this side, means the next direction should be this side, and next direction should be this side, it should be forward direction. Okay, that is the first force, the tail of the first forces and the last forces of tip should be touches. Okay, that is the, like this. Okay, then only we are going to call as, this is called as a force polygon. Okay, so this is also very important. So in examination they may ask you what, state the condition for 3-force member anta. Okay, then you have to write the two diagram, that is diagram number 1 and diagram number 2. This is a force diagram. Okay, based on this we are drawn this diagram is called as force polygon. Okay, so okay, so this is about the equilibrium of 3-force member. Okay, the next last one is, so state the condition for a 2-force member with torque. Okay, so normally what is the condition for 2-force member on a particular given element, means the two forces should be act opposite each other. Okay, and in the same line and the same magnitude, that is for only the 2-force member. But whereas with the torque, okay, so look at here the diagram here. Okay, so this is the element 1 to 2 is the element. Okay, that is a force element. Okay, at point 1 the force F1 is acting, at force 2 the F2 is acting. Okay, so if because of these forces a torque will be produced, that is moment will be produced. Okay, that we need to find torque is equal to F1 into H with respect to, if you want to consider from this point, if you consider with respect to 2 means F2 into H. Okay, so this is a formula for torque, Newton into Newton mm. Okay, that is a unit for this torque. Okay, so you have to write in the examination diagram with these three conditions. Okay, so when we are going to say the 2-force member is in equilibrium, 2-force member with torque is static equilibrium, so here the force should be acting, the forces are equal in magnitude. Okay, if F1 is acting 10 Newton, means F2 should is always it should be act only 10 Newton. Okay, so the forces are in equal in magnitude. Okay, and the second condition is the both the forces are in parallel to each other. Okay, that is parallel to each other, that is if you draw F1 is like this, you have to draw the exact opposite and parallel to F1. Okay, that is keep on scale on this point and just to drag with and opposite direction, you have to just to draw the line. Okay, so this is the second condition and both are in opposite direction. Okay, so this is the condition, these are the three conditions for the 2-force member with torque. Okay, I will repeat, if the what is the condition for 3-force member, that is the 2-force member with torque, the both the forces equal magnitude, opposite in direction, and these F1 and F2 should be parallel to each other. Okay, then you measure from, and you just to extend this F1 line and F2 line, just to measure the height, then you find the torque. Okay, that is torque is equal to F1 into H or F2 into H, so you are going to get the torque value. Okay, so this is very important slide, this is very important PPT. So all this is what I told you in the 4 cases, that is a static equilibrium and 2-force member, 3-force member, 2-force member with torque. So all these cases I am going to use the while solving the problems of static and dynamic force analysis problem. Okay, so this is very important. Okay, so I will repeat once again. Okay, so here look at the conditions. Okay, so look at here the static equilibrium condition. Static equilibrium condition means what? The summation of force. What is the condition? The summation of forces is equal to 0 and the moment produced on that any arbitrary axis is equal to 0. Okay, so second case is, what is the condition for 2-force member? Here the both the forces in equal magnitude. Okay, and opposite in direction, and both the forces are both the forces are acting on the same line. Okay, that is a condition for what? 2-force member. And what is the condition for 3-force member? The forces acting on a given element should meet at a point, that point is called as a point of concurrency. Okay, so that is called as that is a condition for this equilibrium of 3-force member. Okay, then the member with 2-force member and torque means, what is the condition here? There are 3 conditions. So first condition is what? Both forces, that is both the forces acting on given element should be equal magnitude, and they are in parallel to each other, and okay, then opposite direction. Okay, so these are the condition for this force. and this is very very important for the point of examination, so you have to remember. Okay, so it is a fixed question if you, okay. So I hope you understand this. Okay, well, in the next slide I'm going to solve the numerical problems on based on this topic. Okay, so I hope you understand this. Okay, thank you very much.